Hello, welcome to another video on Vtuber's Intro to Organic Chemistry, and today we'll be talking about functional groups. So just a quick note about memorization. If you're taking an organic chemistry course, there's gonna be a lot of memorization. This comes from nomenclature, reactions and what the reactions are, and functional groups. My advice is do problems over time or study over time. You could do flashcards, active recall, repeated writing, whatever works for you. Just do them over time and don't wait until the last day to cram. So let's go into functional groups and what they are. A functional group is a part of the molecule that is reactive. That is, it can lead to actual chemical reactions. So if something is more reactive, is more of a chance of making something happen. This is not really a great example, but if you throw a bomb near fire, it's gonna explode. So what I'm trying to say is that it's the opposite of being inert. Something inert like noble gases doesn't really do much compared to something like dynamite, which has the capacity to like explode and be really reactive. Functional groups are usually a part of an organic molecule as a substituent. I'm gonna go more in depth about substituents in another video, but basically just think of substituents as additions to your main body, like your torso, right? You have a torso, and I would think of your arms and legs as substituents or add-ons to your torso body. So this entire list here is meant to stress you out, definitely. My point showing this is that there are a lot of things to learn. You're not going to learn this in one day, and I'm going to go back to my point about memorization. Just do things over time. It's going to come naturally. But for now, let's just focus on 10 functional groups I think you will encounter mostly in your first few weeks of Intro to Organic Chemistry. Let's start off with alcohols and diols. First of all, if you remember the 4-3-2-1 rule, oxygen likes to form two bonds. Why is that? Because it has a valence of 6. It gets kind of complicated, but what I'm trying to say is that oxygen and sulfur are in the same group. They have the same valence, have the same valence electrons. So you would expect their structures as functional groups to be slightly similar. So here are the structures of alcohols and diols. You have R bonded to an OH. This OH over here is what we call an alcohol group. It's also synonymous with hydroxyl group. You might see in textbooks or in language somewhere. A diol group is similar in that it's R bonded to an SH. This SH group right here is a diol group. Now, R stands for rest of the molecule, and usually the rest of the molecule is what you considered your main chain, and that's usually comprised of mainly carbon and hydrogen. So every time you see an R, just think of it as a carbon or hydrogen. Amine, whatever you would like to call it, but that and nitriles. So both of these groups contain a nitrogen atom. Again, remember the 4-3-2-1 rule. Nitrogen likes to form 3 bonds in an uncharged stable molecule. So this is the general form of an amine. It's a nitrogen bonded to 3 different things. I write R groups here. These could be carbons, these could be hydrogens, and just a little note, amines can be classified as primary, secondary, and tertiary. We can go more in depth about this in a later video, but basically primary, tertiary, and secondary all depends on how many carbons the nitrogen is bonded to. If it's bonded to 1 carbon, it would be a primary. If it's bonded to 3 carbons, with all the R's being carbons, it would be a tertiary amine. Nitriles are carbon bonded. Nitriles are groups where carbon is triple bonded to a nitrogen. So over here, this would be a nitro group bonded to the rest of the molecule. Alkene, alkyne, and arenes, also known as aromatic functional groups, they're all related to bonds between carbons and usually have double or triple bonds. So let's go over what an alkene is. Alkene is just a carbon double bonded to a carbon. and that's pretty much all it is. Alkyne is a carbon triple bonded to a carbon, and again, that's pretty much all it is. And arene, or an aromatic group, is basically saying the molecule has a benzene ring attached to it. So if this was the main chain, right, your main backbone of the molecule, it has a benzene ring attached to it. So the molecule will be considered an aromatic or arene compound. Ether and ester groups. Both of these groups contain oxygen atoms, and an ether is simply an oxygen attached to two different things. That's pretty much all it is. We typically see ethers as being attached to two carbons. If it's attached to hydrogen over here, that would be considered a alcohol group, and if it's if it's two hydrogens, that would just be a water molecule. Ester groups are a little bit different. It contains a carbonyl group, which is a carbon double bonded to an oxygen. We'll go more over this in the next slide, but for now, it just is a carbon double bonded to an oxygen and bonded to another oxygen. So this right here is a structure of an ester. Ketone, aldehyde, and carboxylic acids. All of these groups, including ester, contains a carbonyl group, which is, as I circled, is a carbon double bonded to an oxygen. So these two are extremely similar. So it's just a carbonyl group. For ketones, it's usually within the molecule itself, and I'll explain what this means later. So these two are more terminal. These are terminal functional groups. They're at the ends. They stop the molecule from branching any further. This is more in the middle. I forgot the name, maybe intramolecular functional group, but I'll show what that means. But in general, ketone is just carbon bonded, double bond to an oxygen. Aldehyde, carbon double bond to an oxygen and bonded to an hydrogen. Carboxylic acid, carbon double bond to an oxygen and bonded to an hydroxy group, COOH. Alright, to sum it all up and to just show you what I mean by different functional groups, let's start off with A. So you can see C double bond to an O, bond to an OH. This would be a carboxylic acid. And going back to my point about being terminal, it's at the end of the molecule, so it stops the branching. Let's find where an aldehyde is. Okay, here's an aldehyde. So this would be L. So you see C double bond to an O, bond to an H. It stops the branching. This is a terminal functional group, similar to a carboxylic acid. Let's move on to B. B, you see carbon double bonded to a carbon. This will be an alkene group. Over here, we see a ketone, right? It's in the middle of the molecule and is a carbon double bonded to an oxygen. I'll just say these as carbonyl groups in the future. And over here we see an alcohol group, carbon bonded to an OH. Over here, carbonyl group bonded to an oxygen. This would be an ester group. Over here we see carbon bonded to a pH. What is a pH? pH stands for phenol group, and typically this is just a representation of a aromatic ring or benzene ring. Again, remember the laziness of organic chemists. We just want to be as efficient as possible. So every time you see a pH, just think phenol group and just think that's a benzene ring. Okay, over here we see an oxygen bonded to two carbons, a ether group. Over here, nitrogen bonded to three things. That's a amine. How many carbons is it bonded to though? It's bonded to one carbon, not three, not two. So this would be a primary amine. Over here, carbon bonded to an SH. This right here is a diol group. Over here, carbon triple bonded to a nitrogen. This here would be a nitrile group. Over here, carbon triple bonded to another carbon. That would be an alkyne group. And again, we went over this. Carbonyl group bonded to an hydrogen, an aldehyde group. And we know this because it's at end. It's a terminal functional group. So again, there are more, as I showed you, there are so many different more functional groups. Relax and just focus on the basic ones I showed you right now and just slowly expand your knowledge. is extremely similar to like Pokemon. You start off with like, you know, Pikachu, Charmander, Bulbasaur, right? And then as you play the game, you slowly understand the names of the other Pokemons until you get to something like Dragonite, right? You're not gonna remember all the names of the Pokemon in one day. It's over time and with repetition. And my final point is, don't be too hard on yourself. This is difficult stuff to learn and to memorize. I did extremely poorly in this section when I learned it. And right now, I can name every single functional group from my mind right now. So it's just a matter of not giving up and just keep trying and, you know, just go at it. Don't give up. I would give this advice for any other course you're taking right now if you are. And finally, here are just socials. The song is from Ninomae Ina'nis, one of my favorite VTubers. Her background music for her drawing stream, loading screens, I don't know, but I'll put it in the description. Check it out. Check her out. She's great. And finally, drink water, eat healthy, sleep 8 hours, exercise daily, and everything will be alright. Thanks for watching.